In this video, we will learn how to derive an ordinary demand function in a two-commodity model framework, and we have to prove that ordinary demand function is homogeneous of degree 0 with respect to all prices and income. Okay, so in two-commodity framework, an ordinary demand function, what we call the Marshallian demand function, can be derived by maximizing the consumer's utility subject to the budget constraint. Okay, so let's take a utility function. Let us say utility is a function of two goods, x comma y, which are related like this, x times y. So we take this utility function and we want to maximize. To find out the ordinary demand function, what we do, we want to maximize the utility of the consumer deriving from consuming goods x and y subject to the budget constraint that he or she will be facing. That is, what will be the budget constraint? That is price of good x times units of good x consumed plus price of y times units of good y consumed, and it should be equal to the income of the consumer. Okay, so graphically what we are supposed to do, so if I draw a graph, we take good x on the horizontal axis, good y on the vertical axis. This tells us that with a given budget set or with a given budget, okay, let us say this is budget line, consumer want to reach to the highest satisfaction or utility. So we take the indifference curve, which is our utility function. Let us say this is IC1, and let us take another utility function. Let us say this is IC2. Now consumer's optimal consumption bundle or demand for good x and y will be at a point where the indifference curve and the budget line are tangent to each other. That will give us the ordinary demand function in a two commodity model. So we will get here x star and y star. Now at this point where they are tangent to each other, the condition is that at a point of tangency, the marginal rate of substitution between good x and y should be equal to the ratio of the prices of good x and price of good y. Okay, now this MRS denotes the slope of indifference curve, and this px upon py denotes the slope of budget line. Okay, at the point of tangency, slope of the indifference curve and the slope of budget line are equal. MRS, as we know, it is simply the ratio of the marginal utility of good x and marginal utility of good y, and we equate it with the ratio of the prices. Okay, now marginal utility of good x is simply the change in the total utility due to the change in the consumption of good x. Likewise, marginal utility of good y is the change in the total utility due to the change in the consumption of good y, and it should be equal to the ratio of the prices, price of x upon price of y. Now du upon dx is the partial derivative of the demand function, of the utility function with respect to x. Derivative of x is 1, so we are left with y, divided by du upon dy means the partial derivative of this function with respect to y, so derivative of y is 1, so we are left with x, and we equate it with the ratio of the prices. Now we need to solve it for y here first, so y will be equal to price of x upon price of y, transpose this x, it gets multiplied here. Then what will we do? We plug the value of y into the budget constraint. So we have price of x times x plus price of y times the value of y is this, price of x upon price of y times x, and it should be equal to the income of the consumer. Here price of y and y gets cancelled, so we have px into x, p and px into x, so this is twice px into x is equal to income dividing both sides by 2px. That means x is equal to m upon 2px. This denotes the demand function for good, ordinary demand function for good x. By ordinary demand function, what we mean when the demand for a good is a function of income and prices. Okay, here we can see. Likewise, demand function for good y will be equal to m upon 2py. How do I get this? Plug this value into this equation, you will get this value. Okay. Now we also need to prove that this ordinary demand function is homogeneous of degree 0 with respect to all prices and income. By homogeneous function, what we mean? A function where multiplying the variables by a constant factor results in the output being multiplied by that constant raised to some power. Okay, so let me explain it here. So let us say if we have this function f of x, y, this is our function. I am saying this function is homogeneous of degree n. Let us suppose if I multiply each variable, that is x by lambda x and y by lambda x, lambda y, and if I get it in this form, that is lambda raised power n times the original function, that is f of x comma y, I say this function is homogeneous of degree n. Okay, so degree of homogeneity is this power here. If it is 1, we say this given function is homogeneous of degree 1. Okay, so in this context, what we are being given, let us rewrite it here. So let us take this function x star. Here you can see it's a function of prices and income, that is px and income. Okay, now to prove that it is homogeneous of degree 0, what we do, and which in fact is equal to m upon 2px. To prove it is homogeneous of degree 0, we multiply each input, here input is prices and income, by a factor lambda, let us say. That means what will we do if we increase both price of x and price of m by some constant factor, that is if I increase price of x by lambda px and income by same lambda, that means in place of m we have lambda m upon in place of px we have lambda px. So we have lambda upon lambda times m upon 2 px. That gives us f of lambda px lambda m is equal to, since we have lambda here, can we rewrite it like this? Lambda raised power lambda times sorry if I transpose this to numerator, its exponent sign will change, so it becomes -1 times m upon 2px, which is in fact equal to, so since base are same, we can add the exponents. So we have lambda raised power 1 minus 1 times m upon 2px. That means f of lambda px lambda m is equal to, so lambda raised power 0 here we will get, times what is m upon 2px, this is our original demand function, that is equal to f of p of x and m. Here you can see when we increased both factors by both variables by a factor lambda, demand increased by a factor lambda raised power 0. So how do we interpret it? It simply tells us if we increase both income and price by a factor lambda, demand will not increase at all. By homogeneous of degree 0 means doubling the income and prices will not double our demand for good X. Okay, so the intuition is pretty simple. Here let us say consumer is consuming. Let us say consumer is consuming. How do I interpret it here? I don't have the space, So let us say price of good X was 5, income of the consumer was, let us say, 50. Okay, what will be the consumer demanding? In this case, let us suppose 50 divided by price of X, which is 5, which comes out to be 10. Okay, so initially when price of good X was 5, income of the consumer was 50, consumer was demanding 10 units of good X. Now if both prices and income are doubled, what happens? New price will be, let us say, price px prime is from 5 to 10, it gets doubled. Income also gets doubled to 50 to 100. How many units will consumer demand? You can see, so new income is 100 upon 10. Again we are getting 10. That means doubling the income and prices does not affect the demand. Demand remains same. That is the intuition behind homogeneous of degree 0 with respect to prices and income of an ordinary demand function. I hope you find it helpful. Thank you.